For now, no, sir, I guess.
Yeah. Okay. Okay.
Sir, I have a question.
Yeah.
For the midterm, what will be covered in the test?
Yeah. It cover from first week until tomorrow.
So in this meeting, are we like rehashing the stuff that we've learned, or are you gonna teach us new stuff?
In this week, we will learn about the distribution that you have made, that you have uploaded at group discussion, a group WhatsApp.
Okay, okay. Thank you, sir.
Yeah. So we're gonna start, and I need you to explain, what you have been uploaded at group. Maybe we start with the exponential distributions. Group 1, the group member consists of Imade Mahesa Putranata, Anindya Widyadari, RD Hernando Davis, and Muhammad Hakim Sudaryono. Maybe representative of the group, please make some explanations.
Hello, sir. Okay,
Yes.
can you give me a few minutes to prepare?
Yes.
Okay, thank you, sir.
I think most of us are still like taking a shower and stuff, sir, because we just got back from UI. So that's the reason why there's only 8 people in the Zoom.
Yeah. No problem. Yeah.
like fully understand the material yet. But as the name said, like exponential distribution, the graph is it's very exponential, like sorry, the graph looks like a slide either down or up for the exponential probability. And here we can see the function, which is p x. Okay, I'm really sorry, sir. I still I don't know how to do this because the team, the other teammates, like Mahesa, it just like I just got the news that he got into a crash, so I don't know, and I got no like info about the others.
Okay, I'm sad to hear that about the crash from Mahesa. Yeah.
Yes, sir.
Yeah. I hope she get well soon. I mean, no heart problem at all. But yeah, we expect and we pray for her. But anyway, RD, which
Yes, sir.
which part that you have met? I understand that this is a report or result from group works, but which part that your works from this point, from this slide?
Okay, so I'm really sorry, sir, but I think like when we want to discuss it, like suddenly like Mahesa just like he made it all by himself.
Okay.
So yeah.
Okay. I appreciate with your honest, but it is it's very much better if people in the same group understand what they made actually. Okay, maybe we can suspend. I mean, we can suspend your explanation later. We shift to the next group. Okay, after we have exponential.
Sorry, sir. I'll try to do my best the next time. Thank you, sir.
Yeah. Exponential distribution, and then we move forward to the chi-square distribution. Chi-square distribution, the group that already met is Amadeo Giannino Uneputi, and then Andrew Benhard Nugroho, Satyandika Adirajasa, and Muhammad Dava Nugraha. Okay, please, one of the member explain the chi-square distributions.
Yo, Sat, can you share screen, the slide?
Me?
Yeah. I'll try to explain it as best as I can.
That I don't think I can share screen.
Oh, Andrew, can you share screen? Oh, Andrew baru connect. Wait a sec, sir. Andrew, can you share screen, our presentation? Andrew?
Give me some time.
Drew, can you share your screen or no?
Okay.
So it's quite in the same vein as Erdi's team, where honestly none of us really had a clue as to what a chi squared distribution is. So we try to understand it to the best that we can, and this is what we gathered from it. So that's why the slide is like quite it's like lacking information, like proper information, because even while we were making it, we still really had a hard time of trying to understand what a chi-squared distribution is. So, but from what we found anyway, the probability function formula is as shown on screen, and there's also the example of a chi-square distribution, and then the mean of the distribution is also equal to the degree of freedom, and then the variance is equal to 2 times of the degree of freedom. And then the degree of freedom is apparently like an observed value. Like it's still very hard to understand, sir. Like from what we know, chi squared distribution or like statistic is very unique to say the least, because like even in its use case it's so uncommon. Like for example, it's used to like study the underlying distribution and then to test deviations. Like none of it really clicks yet, because yeah, there's barely any explanation for it online. So I'm sorry if our explanation is very lacking. That's it, sir.
Okay. Okay, Dava. Thank you. Anyway, since you have difficulty to understand the chi-square distribution, and then I have a question: which part that you still don't understand about the chi-square distribution, or what kind of questions you have?
I think I might be able to speak for my team, and that is we really don't understand the chi distribution at its core, like what it's used for, or like its application, or even like how to calculate it. It's like very. It's not weird, but it's like very unique, I guess. Like there's like degrees of freedom, and then there's like observed value, expected value, such and such, and also even in the website that we used to learn, it said that the calculations for chi-square distribution is like usually very lengthy and tedious. So even the website tells us to use like applications if we want to use a chi-square distribution. So that's why it's like super hard for us to actually understand what it is.
Okay, no problem. And then we try to understand together. Actually, can you show me what kind of this graph? Can you guys explain about this graph?
Well, I guess okay. So I got that graph from a website, statistics go to, and in the website it said that the graph is like a representation of a gamma distribution, which I genuinely don't understand what that means. And then it uses the n is like degree of freedom, which I also still don't really know. So it like handles gamma distribution and then degrees of freedom, such and such. So yeah, like I can tell you what the website is trying to explain, but the explanation is still like too advanced to like for my team to understand at least.
Okay. The thing that I mean, the question is actually what is the x-axis and what is the y-axis?
So I'm guessing the x-axis is a degree of freedom. Maybe. I'm genuinely not sure. I think it's the degree of freedom, and then the x is like the gamma distribution, perhaps. I really can't lie to you, sir. Like I'm genuinely not sure.
Okay. Do you remember about the normal distributions that we already discussed last week?
Kind of, yeah.
Yeah. So please draw some normal distribution in this screen.
All right, I'll switch over to my teammates, I guess, for this one. Satya or Andrew, you can go ahead. Apa namanya? Draw the normal distribution. Thank you.
Draw the itu.
Normal distribution. Wait a second, sir. We're still. Should we draw it, or can we just take a Google image of it?
Yeah, up to you. You can draw it. It's more simple, I think.
Wait, say I'm a draw. I'm a draw it. That's standard normal distribution sih.
Okay, please explain.
Sat, you there?
Which one? I see your works.
This is the standard normal distribution sih.
Which one? Can you explain with handwriting, for example?
it's very hard for me to handwrite on the phone. So.
Why you use a computer or handphone or tablet?
Handphone, it's too small.
No. Maybe your friend or in your group, maybe you can helps, assist.
Andrew, can you try to draw it? I'm sorry. I'm on trackpad. Can't really draw. I guess Andrew can try to draw, and then Satya's gonna try to explain.
Can you see my annotation on the top right? See?
Yes.
So basically, this part is the normal distribution.
Hmm?
It's like the average, and since it's normally like on this part, uh, like the this became well, it's not near accurate or not frequently occurring in the real life situation. And the higher peak is, the more the likely it happens. I think that's the best I can do for explaining.
Okay. Once you explain the graph, first better to mention the x-axis and the y-axis, and what is the meaning of x-axis, what is the meaning of y-axis. Can you rewind your explanation by mentioning what is the meaning of x-axis and the meaning of y-axis?
The y-axis represents the probability, see,
Okay.
of how likely it to happen, and the x-axis is the points, like the values.
Okay. And then explain the pattern of the graph.
By pattern, you mean what? Say?
Yeah, the behavior of the pattern. You mean maybe the graph start from which point and ends in which point, something like that.
I'll try my best, but but the graph starts around here, say. Oh, wait. Uh, wait. Wait. The pattern of the graph is like the hilly sections. As I mentioned before, the y is the probability, and the x is the occurrence, what was occurring. And by all means, usually man is in the middle, so it's on the peak or the top, and the getting further away from the middle, it's getting less probability.
Okay. And then when we talk about the chi-square distribution, what is the difference between them? Between normal distribution and chi-square distribution by looking at the graph?
The graph is different. Yeah.
Okay, why it is different? What kind of difference that you can mention?
The difference, I think it's only like one drop, like this, but I don't know if maybe somebody on my team could explain.
What were you asking, Seth?
Yeah. My question is, compared to the normal distributions, what is the differences between normal distribution and chi-square distribution by looking at the graph?
Just from observation alone, I guess in normal
Yeah.
distribution.
Yeah, just from the observation, you can
Okay.
look at the graph from the
So from
screen.
the observation alone, in normal distribution, there is usually a peak in the middle, and like it fizzles out in the end, and it ramps up in the left one. But in chi-squared distribution, it seems like it's not really random, but the peak is more. It's not as evenly distributed. I guess that's what I wanted to say. In normal distribution, there's usually like a peak in the very middle of like the line, where in chi-squared distribution, the peak can be like in the start or in the middle, or even it can be a valley as seen in the green and yellow line. I guess from observation alone, that's what I could gather.
How about from the x-axis?
From the x-axis, um, in normal distribution, the x-axis is what was it again, Seth? Was it the x-axis is the chance of it happening, like the probability? Oh no. The x-axis is the. Oh my God! Wait. Like I completely forgot. Sat, can you help me out?
The y-axis is the probability. The x-axis is what is occurring.
Oh yeah. So I guess in chi squared, the base of occurrence is like there's many to it. It's not really set in the middle. That's all I guess. Like if in normal square, it's like always in the middle of of the line. There's always a bump in like highest probability of happening. But in chi squared, it's like it can be slanted, or the bump can be at the start of the line, or it can be at the end of the line. Yeah,
Can
that's
you
all.
see from the spectrum? I mean, can you see from the range of x-axis? Can you make a distinguish? Can you distinguish
As in what, sir? I'm sorry.
the range of x?
I think it could continue like further away.
Oh, so it continues until I guess it never stops. Is that what you're trying to say? Like in the graph that we showed, there's really no end to it. Like maybe the yellow line touches 8, but I guess like the purple and the reds, they really go on.
Okay. From the endpoint, it is correct that we both of distribution have an infinity point, but from the beginning there is some differences. You can see when we talk about the normal, we start from minus infinity, right?
Yeah.
Yes. How about the chi-square? We start from minus infinity, or we start from 0, or
I think we start from
Oh, so yeah. In G squared, 4 of the lines start at 0, but I guess there's 2 that starts like the yellow one doesn't start from anything, sir. So what should we make of it?
yeah, that's the sum of the differences between normal distribution and chi-square distributions. Actually, from this range in x-axis, you can see, you can make a you can distinguish between them. Actually, from chi-square, we always start from 0. There is no minus, yeah. There is no minus observations in the chi-square distributions. And why this is not minus? Maybe some of you already explore. That's because every random variable should be multiplied by itself. Yeah, you can see here that every random variable should be squared, yeah, powered by 2. That's why there is no minus random variables in chi-square distributions. Yeah, I suggest you all that when you explain the graph, this graph, what kind of this graph? Actually, this graph is probability distribution. Okay, probability distribution, and if we look at to the pattern of this graph, it's follow chi-square distributions. Why we call chi-square? Because you can see here the x-axis start from 0, and then because this is the probability distribution, it always that x-axis is the random variables and the y-axis it is a probability. Okay, and another unique feature from chi-square distribution, there is k. The k will be equal to 1, 2, 3, 4, and infinity. What is the meaning of k? The meaning of k is free, what we call random free number. What actually means that you can see that chi-square is consists of can be many, yeah, can be more than random variable edge point. It's composed or it's result of summations from many random variable. For example, in this point, you can see here, if we using one free factor, yeah, you can see here k equal to 1. It's mean that the random variable only consists one random variable each point. But if we have k equal to 2, it's mean the degree of freedom, yeah, the degree of freedom is 2. It's mean that in each point here consists of at least two random variable, yeah. If we, you can see here from the green one is consists only two random variable in every occurrence. And then for the three, for the is like green Tosca, maybe for this is for blue, this is for which one? Purple, and this is for red. Yeah. As we increase the number of random variable in each occurrence, and then the probability will be shifted to the right. Yeah, you can see the pattern. And then given this the distributions, and then we should know the mean, yeah, and the variance. The mean and the variance actually what is the meaning of phi? I don't know, but the mean is equal to the key, the degree of freedom, and for the variance, 2 times k, 2 times k, yeah.
The V is the degree of freedom. So I guess the V is the K in that case.
Okay, okay, yeah. You should be consistent for writing the variables. When you use a k in this graph, it is better to write the same variable at the narrations. Yeah.
Yes, we are very sorry.
Okay. Okay. That's all when we talk about the chi-square distributions. And
I'm sorry, I have a question. This
yeah.
might be a topic, but so when do we actually use chi-square distribution? Is it just another
Hmm.
distribution type that's like niche, I guess? Like when do we actually use it? Because I still don't even understand the use case of it. Even the website that tells us its use case, it's still like gibberish, I guess. Like,
Okay.
um,
Okay. Very good questions. Actually, when the chi-square distribution can be used, actually we should look at the behavior of random variable. The unique feature from these chi-square distributions, if the random variable, I mean the occurrence of the random variables, never negative, and each occurrence, and I mean each point here, it should be powered by 2. It should be, the value, it should be powered by 2. For example, the random variable that follow this kind of behavior is when we calculating the power of electricity. You remember, the power actually is V power by 2 multiplied by a resistance, right? And if the power is random, I mean, the phi is random, and then we can derive that the power is follow chi-square distributions, because each random variable here is a result of computation power, voltage power by 2, something like that. You can see it's follow the behavior of random variable, something like that. Can you understand about what I have explained?
Yeah, I guess it like explains it more than the stuff that's in the websites. That's for sure.
Okay. Is there any questions? Maybe not only from this group, but from other groups.
So I have questions,
Yes.
sir. I still don't understand when we use the binomial, when we use the normal distribution, and when we use the chi-squared. I'm like, there's a lot of type of distribution, and yeah, I just want to know when we use each of them.
You mean the applications?
Yes, like the application and the meaning of each distribution.
Okay, maybe from the meaning, the meaning is from each kind of probability distribution is same. It tells about the random variable behave. actually. The behavior of random variables and then can be reflect or we can be seen from the pattern of the graph. From the pattern of the graph. For example, here, wait a moment, I will tell you. Yeah, can you see my screen? Yeah, you can see
Yes,
here.
sir.
Yeah, you can see. For example, this is a chi-square distribution that I take from Wikipedia, and then you can see how the random variable here behave. You can see, for example, for k equal to 3, the probability will likely occur at the lowest number. You can see here, this is the highest probability is around here. But as the degree of freedom increase, you can see here, increase the red one. This is shift to the right. It's mean that it's around here, maybe 9 here, something like that. And for example, key equal to 6 is like this. Yeah, something like that. It just tells the random variable behave. And again, this probability density, the probability distributions functions is kind of like a function. Yeah, it's just like a function. It's mean that there is no, how to say, there is no exact. I mean, when you make an experiment, for example, taking some random phenomena and then you draw the result into the histogram, and then it's realized that it's like a follow some distributions, something like that. That's the meaning. And then for the applications is, yeah, it can be, how to say, the chi-square distributions. The application is referred to the behavior of random variable. You can see here the random variable is never negative. It's mean that if you have an experiment that resulting the occurrence that non-negative, that negative values never happen, it might be, or it can be modeled using chi-square distribution. Maybe the word that I use is, it can be considered that it's likely chi-square distribution. It's kind of like that.
So the graph is based on the data. For example, if I do an experiment and then I plot it to the graph, then how do you say it? Like, yeah, the graph is based on the data that we get. I mean, like we can use any type of distribution, depends on our data.
Yes, it depends on your data and how the pattern looks like.
So if we get the data and then we plot it into the graph, and then the graph is shaped like binomial distribution, then we use the binomial distribution. Is it like that?
Yes, actually.
Oh, okay, sir. Thank you.
Yes. So the point when we learn about the probability distribution, whether we talking about it discrete or continue, actually we learn about any possibility of distributions. Okay. Yeah, for example, we draw from the experiment, and we draw the experiment, and then this is the frequency, let's say. Actually, we already done at the beginning, right? For example, the y-axis is the frequency, and the x-axis is the occurrence range of the random variables. For example, if the random variable some occurrence is from the negative, like might be -1 and or minus yeah some number, and then it's kind of like this, and this after the observation you got kind of this graph, and then it's likely to be a normal distributions. It's likely, yeah, it's likely to be normal distribution. And then if you got the experiment, the data from the experiment, and then you draw the data, that's realized that it's kind of like this, and this consistent, and it's maybe follow some exponential distributions. And if the graph is being like this, it's maybe it's follow the chi-square distribution. Because each probability functions, it's like a chi, exponential, normal distribution, they have unique function, unique mathematical functions. Unique mathematical functions. So we can easily differentiate them. Moreover, for the beta distribution that you have made, or log normal distributions, wait a moment. Yeah, like a log normal distribution, you can see it's kind of a normal distributions, but start from 0. There is no negative, yeah, no negative function. And you can see here, maybe I should show is, okay, you can see here that the x-axis here, the x-axis is a result of learn, yeah. This is not purely the value, but is result from learn, yeah, learn computations, yeah. So every occurrence, and then we compute the learns, and then we draw the x, and the result is these distributions. This kind of the behavior of the distributions. And again, this is also important, that every probability distribution model has own mean and variance. Since the function is unique, so the mean and the variance also unique. For example, here you can draw the mean here, and for the variance is a bit complicated, likes, yeah, likes complicated. So learn one variance x something. So, and also the beta distribution also is similar. Yeah, it's similar. So the thing that I want to point out here from discussing about the some, it means that several probability distribution, whether so I draw here probability distributions, and then it can be classified into the discrete and continue, and then continue, and then the discrete, and the discrete, it means that the x-axis, the x-axis is a discrete value, and because of discrete, and the graph is maybe is kind of distracted, it means that not continue. There is some gap here, the gap that doesn't exist for the probability. But compared to the continue, it means that in every range of x is always exists the probability continue. And then after that, we realize that there is, yeah, after we talking about this one, and then we move forward, that realize that there are many pattern of what? Pattern of the function here. How the variable x distributed, yeah, how the variable x distributed. That's the meaning of pattern. Allow me explain in bahasa. Jadi setelah kita mengetahui discrete dan kontinunya, maka kita menyadari bahwa si variabel x ini mempunyai pola. Nah, polanya ini unik dari satu ke yang lain. Nah, pola-pola yang unik ini bisa dikarakterisasi dengan apa? Pattern. This pattern can be characterized from the fx. It means that probability density function. From mean. From the variance. That's all. Any questions?
So first we get the data and then we plot it. Then from that we know what kind of distribution we got. Is it like that?
Yes. Once you have a data and then you plot, and then you can
Find the function.
Yeah, you can guess or you can consider what kind of distribution look like that fit to the model, something like that.
Okay, sir.
Okay. Is there any questions? Any other questions?
Sir,
Yes.
so like after collecting the data, plotting it, and like see which like method suitable. So is basically like those method is to represent and to show the data, right? So that we can like read it better to understand that data. Is it like that?
Yeah. It's like that. I mean that for example, in this case, after you get the data and you plot, and then you consider that this kind of data is likely fit to the normal distributions, for example, and then you consider using some function from normal distribution function, and you draw the mean and the variance, something like that.
Okay, sir.
Okay. Is that clear? All? Any questions? Any questions? Okay, after that, so what is the purpose or what is the benefit after we decide or we determine a model from the data? Yeah, for example, you already consider that our data follow, yeah, our data follow normal distribution, for example. And what is the purpose? What is the benefit? And then after that, if you already decided that our data follows normal distribution, you can be confident to compute the probability occurrence. Yeah, let's say this point, this is A, and then you want to know how much the probability of the occurrence greater than A, means that this one, and then you can compute using this function, right? Using the normal function, normal distribution function. That's the point.
Sir, sorry, sir. Could you
Yeah.
repeat that one more time? Oh,
Huh? Huh?
can you repeat what you just said one more time?
Oh, okay. Okay, before I repeat in English, I will explain a bit in bahasa. Jadi begini. Sebagai contoh, misalkan kalian sudah melakukan eksperimen, kemudian kalian sudah mengupload data. Ini fx-nya. Setelah itu, dari data itu, ternyata datanya mungkin seperti ini. Oke. Kalau seperti ini berarti kita cek literatur. Kira-kira dengan bentuk pola, ya, dengan bentuk pola seperti ini kita modelkan dengan apa ya, gitu kan pertanyaannya. Oh, ternyata setelah kita cek berdasarkan literatur, ternyata ini polanya mengikuti probabilitas normal, gitu kan, atau probability normal probability functions, ya. Distribusi normal, gitu kan. Nah, setelah bahwa terus kemudian kita menentukan, oke, distribusi normal, oke. Kemudian dari data juga kan kita bisa memperoleh rata-ratanya, ya, min-nya. Dari data juga kita bisa memperoleh variance, oke, mempunyai variance. Let's say M1 dan variance 1, oke. Ini variance kan dipangkatkan 2, ya. Kemudian karena normal, maka kita bisa tuliskan fungsinya fx. Fx sama dengan fungsi distribusi normal adalah 1 per apa? Akar 2pi sigma kuadrat E pangkat, ya, ini nggak usah dihafal, nyontek boleh. Ini kebetulan saya udah hafal aja. X min mu 1 kuadrat per 2 varians. Seperti ini kan? Nah, oleh karena itu, kita ya tinggal substitusi aja. Ini ke sini. Ini ke sini. Dan ke sini. Sudah. Oke. Ini variabel X, ini menggambarkan nilai di sini. Oke. Nah, terus setelah itu, setelah kita tahu distribusinya, maka apa namanya? Kita bisa menghitung. Pertanyaannya, berapa sih probabilitas X? Misalkan di sini saya punya angka C lah, ya, C gitu ya. Saya ingin menghitung probabilitas X di mana X itu lebih besar sama dengan C. Bagaimana caranya? Nah, karena kita mengetahui bahwa, atau kita ya mengetahui lah ya, atau sudah memutuskan bahwa ini adalah normal distribusi, maka kita bisa menghitung menggunakan ya salah satunya integral dari C sampai dengan tak hingga menggunakan rumus fx dx gitu, menggunakan integral atau menggunakan tabel. Kita bisa menghitung probabilitasnya gitu, atau menghitung probabilitas untuk nilai yang lain, probabilitas x kurang dari sama dengan C. Ya berarti dia sama dengan, di sini saya tulis integral minus tak hingga sampai dengan C, ya, fx dx. Oke. Nah, sebagai contoh, misalkan kita belum menentukan ini normal atau distribusi normal atau distribusi log normal atau distribusi chi square, kita belum menentukan. Maka kita tidak bisa menghitung nilai probabilitasnya. Mungkin kita dari data sudah mendapatkan mean. Mungkin dari data, dari observasi ya, dari eksperimen kita sudah mendapatkan varians. Mean dan varians sudah diperoleh. Tapi kalau modelnya belum tahu, kita belum bisa menentukan probabilitasnya. Gitu. Okay. It is necessary to explain in English?
For me, no, I guess. I
Okay.
kind
How
of get
about
it.
the others? You need explain in English? Hello?
For me, clear, sir.
Clear, yeah? Okay. That's the purpose why we study the many types of probability distribution model. Why choosing or considering the right distribution model is important? Because yeah, it's really affect to the probability. You can see here, this function is really depend on the probability distribution model. When we have wrong decision to choose the right probability model, so we also be wrong to compute the probability, something like that. Okay, I hope it is clear. Is there any questions? Okay, if no questions, we finish our class today. Thank you very much for your attention. Stay healthy and see you tomorrow. Thank you.
Sir.
Thank you, sir.
Yeah.
Thank you very much,
Thank
sir.
you, sir.
Thank you, sir.
Yeah.
Thank you, sir. Thank you so much.
Thank you, sir. Thank you.